Hello, my name is Haley Stevens, and today we will be going over two different questions. And this is number 1. So I wrote out the equation. It gives us a formula, which is what we have to get to. It's also written down right here. It's the same one. And what we have to do is figure out which reaction goes where the question mark is to make this statement true. So we have to add a reaction into this space to make this equation down here. Alright, let's get started. So first off, how I start is I look to see if there's anything on the left side and the right side with the same number in the front. So I'm looking. Okay, and I see AX4 and AX4, and they both have a coefficient of 1. So, and they're on the left and the right side of the equation, so I'm going to cross those two out. And they aren't found down below in the equation, so I cross them out. The second thing that I do is I look to see what's down here in the equation that we have to get to, and I look to see what's on each side of the equation to see which ones I would have to cancel out. So let's start. So AZ2, okay, that's down here, so keep that. 3D2, okay, that's right here. D2, well, we could add that and make 4D2, but down here it's just 3. So I'm gonna circle this. 2x2 is right there, and there's not an A by itself down there. So I'm going to circle that. Then I am going to look on the right side of the equation, and let's see. So AD2, that is actually not down there, so I'm going to circle it. 2ZD2, okay, right there. X2D, right there, and ADX2. Perfect. So we have to cancel out these ones. And what I did was I highlighted the ones that are given that we haven't already used. So this equation has ZX2 and ZX. Okay, well, we don't have either of those, so I'm going to cross that one out. Reaction 4 right here. That one does have D2, but it still has Z, which we aren't using. We're using A and D. This one has Z and X, and we aren't using any of those, so we could cross that one out. Reaction 6 has A, okay, D2, and AD2. Perfect, that's the 3 that we need. So reaction 6 is what we're going to use. So we could get rid of this question mark and put reaction 6. Okay, but the one thing I do see how there's an A and D2 on the left. Well, in reaction 6, there's an A and a D2 on the left as well. But we need them to cancel out. So we're going to flip reaction 6. So we would write it out like this. So it would be AD2 goes to A plus D2. Alright, and on this one, it has a delta H of negative 393.5. But we flipped it, which means it will turn into a positive. Perfect, so we write positive 393.5 kilojoules. And we'll get to that a little later. Okay, and then now that we have this equation, we can cross out the A and the A, the D2 and the D2, and the AD2 and AD2. Perfect. And let's just double check, make sure we're right. Okay, so I see AZ2, okay, 3D2, perfect, and 2x2, okay, and on the right side of the equation, we have 2ZD2, right there, x2d, and ADX2. Perfect. So we have everything. All right. So we got the first step of that equation. Then we have to calculate delta H, which is all over here. So these are our delta H values. And we have the ones that are given to us, and we flipped this one from a negative 393.5 into a positive 393.5. So then all that we have to do is just put it into our calculator. Alright, so it was negative 977 plus a negative 5.2 plus 393.5 plus negative 135.4 equals, perfect, and I got negative 724.1. Alright, and that is our overall delta H value in kilojoules. Alright, so that was part number B for number 1. And part C, so this was A, B, now C. Part C reads, a chemist is studying reaction 1. If they react 2 moles of D2 gas, how many kilojoules of heat will be released? Alright. And if we look at reaction 1, we can see, I'll use this one. We can see that there is 3 D2. So that's going to be important. Perfect. So what we're going to do is we're going to start off with 2 moles, which is what's given. And we are going to convert that, so 2 moles, D2. And since it's already in moles, we can automatically do our mole-to-mole ratio. So what I'm going to do is, just because it's not a 1-to-1 ratio, we can't go right into our next step. So we have to do a mole-to-mole ratio. So I'm going to do 3 moles D2 is equal to, and I'll pick 1 mole of AD2. AD2 is on the right side of the equation, and I'm going to pick this. And when you do that, 2 divided by 3 equal to 0.66, and I'm going to round it to 3 sig figs, so 0.667. And I did this just because there's 3, and that's different than having a 1-to-1 ratio. We have to include that 3. And then what we do is we will do that delta H, which for reaction number 1 is negative 977 kilojoules. So negative 977 kilojoules is equal to Q of the reaction, which I'm going to put as an X because we don't know what that is, over 0.667 moles. And then what I'm going to do is I'm going to go negative 977 times 0.667, which will give us our Q of the reaction. So I got Q of the reaction is equal to negative 651.659. So X or Q of the reaction, either one, is equal to negative 651.659. And I'm going to do that to 3 sig figs since this has 3 and this has 3. So Q of the reaction is equal to negative 652, because it's rounded because of the 6, bumps it up, kilojoules. And there we are. That is question number 1.